Good afternoon, everyone. My name is Ronan, and I will be presenting the Tenacity Mars Rover. Here's the exploded view of the rover. As you can see, lightweight, modern, and functional design were all taken into account through its construction. The overall idea of the Tenacity rover was to improve on previous models' functionality and aesthetics. The shape of the rover chassis is much less boxy than current models, allowing for additional clearance for moving across rocky terrain. The unique shape of the underside of the chassis allows for 360 degrees of rotation from each of the 6 lower suspension arms that connect to the wheels. A rocker bogie suspension system is connected to these lower suspension arms into the chassis, similar to the ones used on current rovers. The suspension system allows the rover to be able to clear obstacles as large as its wheels, as well as be able to move in whatever direction is deemed necessary with a non-existent turn radius. The wheels themselves are fitted with a heavy tread to grip to the Martian surface. The inner rim is modeled after many aftermarket car wheels, reducing weight while preserving strength. An acquisition arm is featured at the front of the rover, has 360 degrees of rotation, and can move in a variety of different directions using multiple rotating and sliding joints throughout its construction. 4 claws connected to a hub equipped with a microscope camera are located at the end of the arm to grab, examine, and be able to identify any unique properties of a certain form material. The main camera is also featured near the front of the rover and is also able to rotate 360 degrees. A simple bolt system allows the camera to be tilted back and forth. The camera features a variety of lenses with different uses to analyze the terrain. When it comes to powering the rover, an updated MMRTG system is the main contributor, housing decaying plutonium and converting the released heat into electricity. To further extend the Tenacity lifespan, 2 solar panels were attached near the rear of the rover chassis by a ball joint, allowing the solar panels to move in a variety of directions to preserve the best angle for receiving sunlight. The table here shows all the fits and tolerances used throughout this assembly. As you can see, a variety of fits were used for specific reasons. For example, transition fits of H7 and 6 were used for each of the joints involving bolts. Transition fits result in a small amount of interference, not enough so that the bolts don't fit, but enough that the threads will lock, holding each part securely in place. Locational clearance fits of H7, H6 were used to connect each of the main components to the chassis. This fit was chosen because locational clearance allows for high accuracy and components to move freely when lubricated, which is necessary for the rotating aspects of certain parts like the arm and camera mast. A driving fit of H7S6 was used to make sure the wheel was securely connected to the wheel hub, as a nut and bolt system was not used as is traditional. Lastly, 2 sliding fits of H7G6 were used to make sure the sliding components of the arm slid smoothly and without any unwanted interference. The general hole and shaft sizes were picked based on the modeled size and estimated weight and wear that each part will end up taking when in the field. So, for example, a hole diameter of 12 millimeters for the wheel and wheel hub joint was chosen.